So problem number 17 says that a place kicker must kick a football from a point 36 meters from the goal, and half the crowd hopes the ball will clear the crossbar, which is 3.05 meters high. When kicked, the ball leaves the ground with a speed of 20 meters per second at an angle of 53 degrees to the horizontal. And the questions are: A, by how much does the ball clear or fall short of clearing the crossbar? B, does the ball approach the crossbar while still rising or while falling? And for this problem, I drew a very exciting diagram. So this is the little place kicker guy. And as you can see, he's 36 meters from the field. What are they called? The goalposts. And the goalposts are 3 meters above the ground. And he kicks his ball at an angle of 53 degrees at an initial velocity of 20 meters per second. So I already drew the little triangle here just to get an example of the different components of the velocity. So first off, it is asking you by how much does the ball clear or fall short of clearing the crossbar. So in order to solve this, I want to figure out how high the ball is when the change in x is 36 meters. When it's at the crossbar, how high is it? If it's less than 3 meters, it hasn't crossed yet. But if it's greater than 3 meters, it has crossed. So I know my initial velocity in the x component is going to be 20 times cosine 53 degrees, which is 12.04 meters per second. I know the initial velocity y component is going to be 20 sine 53 degrees, which is 15.97 meters per second. So initially, I try and find the time when the ball is at this point next to the crossbar, because this will help me solve for the change in y. So I'm using the equation change in x is velocity initial t plus 1/2 at squared, and since the acceleration in the x direction is going to be 0, we can cancel out that part of the equation and just solve change in x is equal to velocity initial t. So we know that the ball reaches the crossbar at approximately 2.99 seconds. I use 3 seconds over here to make it a little bit easier. So we take that information and we use actually the same equation, just with all the y components of everything. So the change in y is the velocity initial y times the time plus 1/2 acceleration t squared. And we know the acceleration in the y direction is going to be negative 9.8 meters per second squared, because I did define the positive y direction is going to be going up. So if you plug everything in, then the change in y at 3 seconds is 3.8 meters, which is greater than 3 meters, so we know that it did clear the crossbar at that time. And then the second question is, does the ball approach the crossbar while rising or while falling? So in order to solve this, I thought we're going to figure out if 3 seconds is past halfway or before halfway of the ball's flight. So in order to do this, I said, okay, what's the time at the top? So at the top, the acceleration, we're working in the y direction here. So the acceleration is negative 9.8 meters per second squared. The velocity initial y is 15.97. And velocity final y at the very top of its apex of its parabolic flight is going to be 0 meters per second. So in order to solve for the time, we just use velocity final as velocity initial plus acceleration times change in time. And to do this, we solve that the time is going to be 1.63 seconds at the top. So we know that it's 1.63 seconds for the ball to get to the top of its arc. So we know that 3 seconds is going to be much later than that, and it's going to be on the way down. So we do know that it crosses the crossbar on the way down. And that's it.